Okay, welcome to lesson 10.2, and this is areas of triangles and of trapezoids. And I call these the half formulas because both of these formulas, as you will see, have a half in them. So let's get right into it. Let's start with the triangle. And both of these formulas are derived from the formula that we just learned. That is the formula for a parallelogram. Now in a parallelogram, just a quick refresher, in a parallelogram we find the base and we find a side or a length that measures perpendicularly between the two parallel bases of the parallelogram, and the area is just equal to the base times the height. And essentially we have to do this when it's leaning over in a parallelogram. We don't have to worry about that in a rectangle because the other side is perpendicular. It acts as the height. Okay, so you can use base times height for rectangles, rhombuses, squares. Some other figures have special formulas, but that's what we're going to base this on. So the way we're going to find the area of a triangle is we're going to picture the triangle. We're going to pick a point right here in the middle of one of the sides, and we're going to rotate the triangle 180 degrees around that. If we do that, what's going to happen is we're going to get a second triangle like this. And so all we're doing is rotating around like this, and so you can see that this angle right here corresponds with the angle up here. Okay, the angle right here corresponds with the angle down here, and finally the little angle, which it looks like the smallest acute angle, is going to correspond with this angle. Okay, and we're going to get parallel sides here and here, and we're going to get parallel sides here and here. So if you think of the yellow and the blue triangles put together, we've just formed a parallelogram. All right, now the parallelogram, if you think about it, okay, we find the area of the parallelogram by doing the base times the height. Okay, and so the area of the whole figure is just base times height. Now keep in mind that the way we created a parallelogram is we took our original yellow triangle and we doubled it. By the way, this height would also copy over here like this, and this is the exact same height upside down. Okay, and so the area of this whole figure is exactly double what we started with. So the area of a triangle is going to be base times height, just like it was in a parallelogram, except since we only have half of a parallelogram, we just put a half out front. So that is the formula for area of a triangle. So we just think of it as half of a parallelogram. So it's the exact same formula with a half, which is why I call these the half formulas. Now, with a trapezoid, it's the same idea, but it's a little more complicated. What we're going to do for a trapezoid is, again, we're going to remember that basic formula of base times height. What we're going to do to turn this one into a parallelogram is we're actually going to make it into a rectangle. So what we're going to do is we're going to take the midpoint, it's about right there and about right here, of the two diagonal sides, the ones that are not parallel. So the parallel sides are here and here. So we take the midpoints of the other two, and we're going to take a line perpendicular to one of the sides, and we're going to draw this in. Now if I take this triangle and I cut it off and I glue it up here, this piece right here that I cut off is going to fill in this piece right here, and it's going to make it kind of like a rectangle. If I do the same thing on the other side, okay, I'm going to do the same thing. I'm going to cut this corner right here off, and I'm going to glue it back in up here, and you'll see that what I've basically just created here is a rectangle. Okay, and the height, or the width of the rectangle, is just the plain old height, same as we had in the parallelogram formula. And the base is a little bit weird, because the base is from here over to here. Well, that's a little bit of a problem, because that's not the little, so look at the yellow sides up here. We had a yellow side here. We're going to call this base 1. It turns out in a trapezoid we call the two parallel sides the bases. And this one down here is base 2. If you look at this blue line right here, we'll just call that plain old regular B. It's neither. It's shorter than B2 and it's longer than B1. But if you think about it, the piece that I cut off right here is the piece I'm missing right there. And the piece that I cut off right here is the piece I'm missing right here. So it turns out that if I connected these two midpoints, obviously the blue lines here, here, and here are all this blue B. Okay? And it turns out that what this blue B is, it's the average of the two yellow B's. It's the average of B1 plus B2. So let's figure out, remember how we average things? We add them together and we divide by how many there are. And that is going to be how we find the blue b. Okay? So the area formula for a trapezoid, you could do it this way. You could go ahead and find the average of the two bases, and then you could just do base times height like we normally do. What most people like to do, though, is they like to build this part right here into the formula. So if we do that, the area of a trapezoid is 1/2, okay, which is the same thing as this. This is b1, okay, plus b2 in parentheses, all times a half. That's the same thing as dividing it by 2. So we're going to do 1/2 of b1 plus b2 in parentheses, which is, again, just remember, that's the same thing as finding the average of b1, b2, and then we're going to multiply that times the height. Okay, now sometimes people will put the height right after the 1/2, and the b1 plus b2 in parentheses will be a little bit further out. But this is the formula for a trapezoid. Now, you can memorize the formula. I don't necessarily recommend just memorizing it. Make sure you remember where it comes from. And so this construction I did, I know if you just look at it right now, it seems like a whole lot of lines. But if you think about where it comes from, we're just going to average the two bases of the trapezoid, add them together and divide by 2 or multiply by half, and then multiply that times the height. So really, both of these formulas just come out of the area of a parallelogram theorem. Let's go ahead and practice a couple of these together. Okay, so the first two are triangles. So remember, the formula is area equals 1/2 the base times the height. So in the first one, it's 1/2 times 6 times 3, and 1/2 times 6 times 3 is 9 units squared. The second triangle is a right triangle, which means that the height, instead of having to be down in the middle like this one was, the height is right here. It's the 4. So the area of this one is 1/2 times the base times the height. Now it doesn't really matter what order you put the 6 and the 4 in, but it's going to work either way. And this one's going to come out to be 12 units squared. Okay, now the bottom two, sorry, that 2 didn't really work. My stylus wasn't cooperating. Okay, the bottom two are the trapezoid formula. And I put these 5s in here, but we don't really need those, do we? Those are the slanty sides. So all we really need is the base 1 and the base 2, and we're going to average those, and you can probably average those in your head. The average is 6 and 8 is going to be 7, and then the height, which is 4. So 7 times 4 is going to equal 28 units squared. If you actually do the formula, it's going to be 1/2 parentheses 6 plus 8 times 4. And 6 plus 8 is 14. Take a half of 14, you get 7, and 7 times 4 equals 28 units squared. And finally, this last one, the area is going to equal 1/2 parentheses 2 plus 7, those are the two bases added together, plus times 3. Okay, so this one's going to be a little harder because it's an odd number, so it's 1/2 times 9, so that's going to give me 9 over 2, times 3, which is 27 over 2. And you can leave it like that, or better yet, let's go ahead and reduce that. That's 13 and 1/2. And again, I don't know if it's going to let me draw a 2 down there. All right, let me change that. We'll make it 13.5. I can probably fit that in a little bit better. We'll say 13.5, and again, it's units squared. Okay? And so that is how I find the area of either a triangle. And so that's a quick review of both the area of a triangle and the area of a trapezoid. Okay, so what I'd like you to do now is I'd like you to pause the video for just a second, and I would like you, you know what, I was going to give you a couple of practice problems, but on second thought, I'm going to stop right there, and we're not going to go over these until class on Friday. Okay, so I will see you on Friday, and we will practice both the area of a triangle and the area of a trapezoid. It'd probably be a good idea to take notes on those two formulas. We'll review them quickly and do a daily quiz on Friday, and then we'll practice these. Okay, so thank you very much for tuning in, and I'm going to sign off, and I'll see you in class. Bye all.